Hello, in today's lab I will be talking about OSPF version 2, Open Shortest Path First. I will activate it using network statements and the wildcard masks. I will be configuring OSPF routing protocol on the interfaces. Now, what is OSPF? The Open Shortest Path First OSPF protocol defined in RFC 2328 is an interior gateway protocol used to distribute routing information within a single autonomous system. OSPF is a routing protocol for Internet Protocol IP networks. It uses a link state routing (LSR) algorithm and falls into the group of interior gateway protocols operating within a single autonomous system (AS). In this topology, I have 3 routers, 3 switches, and 3 LANs. First, I will configure the interfaces on the routers. I will start on router 1. Nothing is configured here on this topology, so on router 1, enable configure terminal. Now I will give it the host name for this router, as always, router 1. Enter. Now I will configure the interfaces. Here we have 3 interfaces on the serial interface as 0/1/0. The other interface here connected to router 3 on the serial interface of S0/1/1, and the third interface connected to the LAN on the gigabit 0/0/0. So I'll start on the interface here, interface 0/1/0. This is with the IP address of 172.16.1.1. This is with a /30 subnet mask of 255.255.255.252, and I will activate this interface with a no shut command. Now on the interface of S0/1/1, this is with the IP address of 172.16.1.21 with /30 subnet mask of 255.255.255.2, and I will enable this interface with a no shut command. Now on the interface of gig 0/0/0, this is with the IP address of 192.168.10.1, but this is with /24 subnet mask of 255.255.255.0, and I will also activate it with a no shut command. So here I'm done with router 1, so I'll move to router 2 here. Enable configure terminal. Now the host name here for this router of router 2. Now I will configure the interfaces here on router 2. The interface of serial 0/1/0. This is with the IP address of 172.16.1.2 with /30 subnet mask of 255.255.255.2, and activated with a no shut command. The other interface on the serial 0/1/1, this is connected to router 3, and this is with the IP address of 172.16.1.9. This is with a /30 subnet mask of 255.255.255.252, and I will activate it or enable it with a no shut command. And finally, the interface on gig 0/0/0 or VLAN 2. This is with the IP address of 192.168.20.1. This is with a /24 subnet mask of 255.255.255.0, and also I will enable it with a no shut command. Now finally we have router 3 here. I will start by enabling it. Let's move it a little bit up. Configure terminal. This is the host name for this router of router 3. Now on the interface of serial 0/1/1 connected to router 2, this is with the IP address of, let me double check here, this is with 172.16.1.10, this is with a /30 subnet mask, and enable it with a no shut command. The interface of serial 0/1/0, this is with the IP address of 172.16.1.22, this is with the /30 subnet mask, and I will enable it with a no shut command. And finally, for the LAN on gig 0/0/0, this is with the IP address of 192.168, this is the 30.1, and this is with a /24 subnet mask, and I will enable it with a no shut command. Now I configured the interfaces on the routers. Now here we have 3 PCs, as you can see, PC 1 on LAN 1, PC 2 on LAN 2, and PC 3. I already configured the IP addresses here, just like PC 1 here, the configuration, as you can see, with the IP address of 192.168.10.10 with /24 subnet mask, and the default gateway is this interface here on gig 0/0/0. And the same with the PC 2. This is the configuration here, and the same here with our PC 3 in LAN 3. And as you can see, I configured the IP address of this PC. Now I will configure the router's IDs. First, I will start the OSPF routing configurations on the routers, and I will use the process ID of 100. So I'll start with router 1 here. Now from the global configuration mode, router OSPF process ID over 100, enter. Now we are in the router configuration mode, and the router ID on router 1 is 1.1.1.1, enter. I will do the same on router 2. From the global configuration mode, router OSPF process ID of 100, and the router ID of 2.2.2.2. The same on router 3, router OSPF 100, and the router ID on router 3.3.3.3.3. I will configure the networks for OSPF routing and using network commands and the wildcard masks. A wildcard mask is a mask of bits that indicates which parts of an IP address are available for examination. In the Cisco IOS, they are used in several places, for example, to indicate the size of a network or subnet for some routing protocols such as OSPF. Now to determine the wildcard mask in seconds, just invert the subnet mask, and that gives you the wildcard mask. The subnet mask here on the LAN, for example LAN 1, is /24, or in binary this is how we write it: 8 ones followed by 8 ones followed by 8 ones, this is 24 bits, followed by 8 zeros. Now what to do is just change those zeros to ones and ones to zeros, and you can have your wildcard mask. When we invert them, the ones to zeros and the zeros is ones, we will have 8 zeros followed by 8 zeros for the second octet, followed by 8 zeros for the third octet, and followed in the fourth octet by 8 ones. This is how we write it, and now in dotted decimal it's 0.0.0.8. The subnet masks between the routers are /30. In dotted decimal it's 255.255.255.252. Now in binary we write them like this: 24 ones followed by 6 ones and 2 zeros. Now what to do is just change those zeros to ones and ones to zeros, and you will have your wildcard mask. And this is how it is when we change the zeros to ones and the ones to zeros. And in dotted decimal, this is how we write them: 0.0.0.3. Now wildcard masks are used to specify a range of network addresses, just like a subnet mask. A wildcard mask is 32-bit long. It's a sort of inverted subnet masks, with the 0 bits indicating that the corresponding bit position must match the same bit position in the IP address. Now what's the difference between subnet mask and wildcard mask? The subnet mask is a 32-bit combination used to describe which portion of an address refers to the subnet or network and which part refers to the host. It's used along with IP address. Now, on the other hand, the wildcard mask is sometimes referred to as an inverted mask because a 1 and 0 mean the opposite of what they mean in a subnet or network mask. From the topology, we have 3 networks are directly connected to the router. How many statements do we need to configure OSPF to route those networks attached to router 1? And we notice that LAN 1 attached to router 1 has a /24 subnet mask. Now I will configure routing process on router 1 with the network statements and the wildcards that are required to activate the OSPF routing for all the attached networks on router 1. We have 3 directly connected networks and all the networks in area 0. Now on router 1 I will use this show command: do show IP route connected. As you can see here, we have these 3 networks directly connected to router 1. Now we need to be in router configuration mode. As you can see here, we are already in router configuration mode. Now as for the network of 172.16.1.0 with the subnet mask, the inverted subnet mask or the wildcard of 0.0.0.3, and this is in area 0. Sorry, go back, we need a dot here, dot, and then hit enter. The other network, which is .20, as you can see here, and now we have the network of the LAN. I'll come back here, 192.168.10.0 with a subnet mask, the wildcard of 0.0.0 here, .255, and in area 0. Hit enter, and I'll type here in. Now I will run this command show run. As you can see here, this is our configuration, router OSPF with a 100, router ID on router 1.1.1.1.1, the network of 172.16.1.0. This is the network between router 1 and router 2, and the other network which is between router 1 and router 3, and the LAN of 192.168.10.0. Now I will configure OSPF on router 2 by using network commands with the interface's IP address and quad 0 mask. Now, what is a quad 0 route? Why is it used? It is used to forward packets to other routers if there is no route entry for the routing table for the router showing network destination. The use of a quad 0 route or a static default route is anonymous with the protocols of dynamic routing. The quad 0 route is a static route with the ability to pair all the packets. Now on router 2, now on router configuration mode, here we have a 3. I will run this command, do show IP interface brief. As you can see here, we have these 3 interfaces. We have the 2 serial interfaces connected to router 1 and router 3, and the interface connecting LAN 2. I will use the same syntax of network commands as I use them on router 1. Now, the network of 172.16.1.2 and the quad 0, and this is in area 0, enter. The second network of 172.16.1.9 with quad 0 and also in area 0, and the third network on this interface of 192.168.20.1, and this is with also quad 0 in area 0. And I'll type here end. Now show run. Here, as you can see, the router OSPF of 100, router ID on router 2 is 2.2.2.2, and these are the networks on these interfaces in area 0. Here, as you can see, again we notice here the 3 network statements for the interface IP addresses and a quad 0 we used during our configuration, plus it's showing us the router ID of 2.2.2.2. Next, on router 3, I will configure OSPF routing on the router's interfaces. On router 3, here we have 3 interfaces here on router. Interface of serial 0/1/0 and the other interface connected to router 2 on the serial 0/1/1, and this interface of gig 0/0/0 connecting LAN 3. So on router 3, this is how we will do the configuration. Enable, sorry about that, enable, I typed in configure terminal, router OSPF 100 from the router configuration. Now on the interface of serial 010 IP OSPF 100 area 0. On the other interface of serial 01/1 IP OSPF 100 area 0, and finally on the gig 0/0/0 connected to LAN 3, this is IP OSPF 100 also in area 0. I will end here and run this show command, show run. As you can see here, router OSPF100, the router ID 3.3.3.3. But now let's go to the interfaces here. We have our interface here of gig 0/0/0. This is how we configured it, the IP OSPF100 area 0. And on this interface, also the second interface of serial 0/1/0, this is connecting to router 2. This is the IP address, IP OSPF100 area 0, and this interface on the serial 0/1/1 connecting router 2 to router 3 with this IP address, IP OSPF100 on area 0. Next, I will configure passive interface. What is passive interface? Interface command is used in all routing protocols to disable sending updates out from a specific interface. However, the command behavior varies from one protocol to another. This simply means that the router will still be able to receive updates on that passive interface and use them in the routing table. Now, what is passive interface on OSPF? If an interface is configured as a passive interface, it does not participate in OSPF and does not establish adjacencies or send routing updates. However, the interface is announced as part of the routing network. Now, why would you want to set an OSPF interface to passive? Configuring a LAN interface as passive eliminates unnecessary OSPF routing information on that interface, freeing up bandwidth. Here in our topology, we have the LAN's interfaces that we will configure as passive interfaces on the interface of gig 0/0/0 interfaces. Now I will start on router 1, configure terminal. Now on router configuration mode, router OSPF100, passive interface on the gig 0/0/0, simply just like that. Enter. Now we'll do the same on router 2. I'll move this a little bit. Configure terminal, router OSPF100, router configuration mode, passive interface on gig 0/0/0. That's it. And on router 3 I'll do the same. Configure terminal, router OSPF100, passive interface on gig 0/0/0. Now I will use the show command to verify OSPF configurations we did on this topology and show the passive interface. Now on router 1 here, I will type show run. And here, as you can see, our passive interface configured on this router is on this interface of gig 0/0/0, as you can see here. And the same on router 2, show run. It's showing us here also the configuration on router 2, that the passive interface on this interface here. This is the passive interface. And the same on router 3, show run. Passive interface on this interface here of gig 0/0/0. Now run on your own these show commands. Like here on router 1, I will type this command, show IP route, enter, and I'll expand it a little bit. Just study this command, see about the connected, directly connected, and also about the O here, which stands for OSPF. Study them. When you reach this point, I'm running this. I'm gonna leave this for you just to study it, what you did so far. The same on router 2 and on router 3. The command is show IP route. Just run this command, see what are the directly connected networks to this router, and about the dynamic routing protocol OSPF, and how just study it and take your time. And also to ping from the PCs to see if they ping each other. I'll start here on PC 1 here from the command prompt. I'll try to ping PC 2 on LAN 2 192.168.20.20 and hit enter. Give it a second, and it is working. Also, trace route your commands, like from PC1, let me say, to PC3 192.168.30.30. Give it a second, and as you can see here, when running the trace route, expand it a little bit, and do the same between the PCs. Try to ping from PC1 to PC2 and PC3, from PC3 to PC2, and just trace route. See how your traffic will be moving from a LAN to another or from a network to another. Just take your time and see how we configured OSPF in this topology. Thank you so much for watching. If you have any comments, any questions, please send me an email and I will gladly answer you back. Thank you so much.